Hey, so you've always wondered what it really means to write a computer program, right? Well, you're in the right place. We're about to pull back the curtain on the absolute basics, the core ideas you need to wrap your head around to get started. Let's just dive right in. So here's our game plan for today. We're going to start with why we even have programming in the first place. Then we'll walk through how an idea in your head becomes a real running app. We'll look at the different languages people use, learn the super important rules for naming things in your code, and then we'll wrap it up with a quick test to make sure it all sticks. All right, let's kick things off with the biggest, most basic question of all. This really gets to the heart of why programming even exists. I mean, we see them do these incredible things, right? They calculate complex equations in a blink, run amazing games. It's so easy to think they're intelligent. But can they actually, think? The answer is probably not what you'd expect. And the answer is a big fat no. A computer is an unbelievably fast and powerful tool, for sure. But it's a tool that does absolutely nothing unless it's told exactly what to do, step by step. It can't guess, it can't improvise, it just follows orders. And that set of orders, that ridiculously detailed recipe we have to give it, that's what we call a program. It's just like a chef needs a recipe to bake a cake. A computer needs a program to do, well, anything. Without one, it's really just a useless box of metal and plastic. Okay, so if a computer needs instructions, how do we get an idea out of our brain and into a language the computer can actually use? Let's take a look at the blueprint every programmer follows. From a bird's eye view, it's a pretty logical process. First, you figure out your goal. What do you want this thing to do? Then, you write the actual instructions. We call that code, in a simple text editor. Next, you have to compile the code. We'll get to that in a sec. Then, you fix all the typos and mistakes. And finally, you run the program and see your idea come to life. Now let's zoom in on that middle part, because that's where the magic happens. After you write your code, a few things happen automatically. A preprocessor comes in and cleans it up a bit. Then the compiler does the most critical job of all. It translates your human-friendly code into machine code, the ones and zeros the computer actually gets. And finally, a linker puts everything together into the final file you can click on and run. Yeah, that word, translation, is everything. Programmers almost never, ever write directly in ones and zeros. I mean, can you imagine? Instead, we use programming languages that act as a bridge between how our human brains think and how the computer's circuits work. And there are different kinds of these languages. On one side, you've got low-level languages like assembly. They're super close to the metal, which makes them incredibly fast, but they're also really hard to read and write. On the other side, you've got high-level languages like Python or C++. These are much closer to plain English. They're way easier to use, but all that convenience means they can be a tiny bit slower. So, you've picked your language. One of the very first things you're going to do when you start writing code is give names to stuff. Names for pieces of data, names for sets of instructions. And just like English or any other language, there are grammar rules you have to follow. Now, the official fancy term for one of these names is an identifier. It's really just a unique label you make up so you can refer to that thing later on. It's how you keep everything organized in your program. And here are the basic rules of the road. First, a name has to start with a letter or an underscore, never ever a number. After that first character, you can use letters, numbers, or underscores. This next one is huge. Names are case sensitive. So myvar with a capital V is a totally different thing from myvar with a lowercase v. And finally, you can't use a name that's already a special command in the language. Those are called reserved keywords. So what kind of stuff do we name? Well, here are the most common things. We name variables, which hold data that can change, like a person's age. We name constants for values that should never change, like the maximum number of players. We name functions, which are just chunks of code we want to reuse. And we name classes, which are like blueprints for building more complex things in our program. Okay, you've seen the rules. Now let's see if you were paying attention. We're going to do a little pop quiz. I'll show you a name. You decide if it's valid. Ready? Let's do it. First up, 3 value. Think back to that number 1 rule we just talked about. Is this a legal name? And nope, you got it. It's invalid. The rule is simple. You just can't start a name with a number. Period. Okay. Next one. How about XYZ? This one starts with that special character. What do you think? And that one is perfectly fine. It's totally valid. Remember the rule? It can start with a letter or an underscore, so this is A-OK.
All right, let's try another. What about abcd? It starts with a letter, so far so good, but what about that thing in the middle?
This one's a no-go. It's invalid. That hyphen is an illegal character. You're only allowed to use letters, numbers, and underscores after that first character. No hyphens, no dollar signs, no question marks.
And for the final boss battle, the word float. It's all letters. Looks like it should be totally fine, right? Ah, and that's the trick. It's invalid. Why? Because float is a reserved keyword. It's a special word that the C++ language already uses for its own purposes, so you can't steal it for your own variable name. It's like trying to name your kid and or the. It just doesn't work.
So there you have it. You've just learned one of the most fundamental skills in all of programming, how to give a name to an idea. It's the very first step in telling a computer what you want it to do. You've seen that a computer is just a tool waiting for your recipe, and now you know the first rule for writing it. The only question left is, what will you create?